Good morning, students. Welcome to my channel. Today's topic, Einstein's energy mass relation. The relation between energy E, mass M, according to Einstein's. So, as per Einstein's mass energy relation, which is displayed on the screen, relativistic mass M is equals to m naught by under root 1 minus v square by c square. Here it is a relativistic mass. So here m naught, rest mass of the body, c velocity of light, v velocity of body, m mass of the body. So m is equals to m naught by under root of 1 minus v square by c square. So we need to prove that is E is equals to mc square. So relativistic mass has given that is m is equals to n naught by the root 1 minus v square by c square. Squaring on both sides. So m square m naught square by squaring on both sides square ki cancel అయిపోతుంది 1 minus v square by c square. So next step 1 minus v square by c square is equals to m naught square. So LCM, so LCM c square minus v square by c square అవుతుంది. m square లోపల మల్టిప్లై చేయొచ్చు. సో m square c square minus m square v square by c square. c square అవతల తీసుకెళ్ళిపోతే m naught square c square. Differentiate above equation. Differentiate above equation. So here c constant, so 2m c square respect to m minus here uv differentiation. So m is also variable, v is also variable. So uv differentiation 2m v square dm minus m square 2v dv is equals to the constant. So constant differentiation 0. So divide this expression with 2m. Divide this expression with 2m. Divide this. So c square dm minus v square dm minus mv dv is equals to 0. Considered as a. c square dm is equals to ఈ టర్మ్ని అవతల తీసుకెళ్ళిపోదాం. v square dm plus mv dv considered as equation 1. A small increase in kinetic energy is equal to the work done in increasing the speed from v to v plus dv. So small increase in kinetic energy, symbolic dk represented, so is equal to the work done increasing the speed, force into, this is equation 2. So here we know that from Newton's second law, force is equals to rate of change of momentum dp by dt. So here momentum, we know that mass into velocity, so u differentiation m into dv by dt plus v into dm by dt. Equation 3. So next step, equation 3, f is equals to m into dv by dt plus v into dm by dt. Equation 3. So equation 3 sub in equation 2 అంటే f ప్లేస్లో ఈ వాల్యూ సబ్స్టిట్యూట్ చేయొచ్చు. ఈక్వేషన్ 3 సబ్ ఇన్ ఈక్వేషన్ 2. What is equation 2? dk is equals to m into dk is equals to ఈ వాల్యూ. సో ఎఫ్ ప్లేస్లో ఈ వాల్యూ సబ్స్టిట్యూట్ చేస్తున్నాం. m into dv by dt. సో ds మల్టిప్లై అవుతుంది ప్లస్ v ఇంటూ dm by dt. ఈక్వేషన్ ఈ 3 వాల్యూని ఈక్వేషన్ 2లో సబ్స్టిట్యూట్ చేసిన ఎఫ్ ప్లేస్లో. దట్స్ ఇట్. సో నెక్స్ట్ we can write like this, ds by dt dv plus v into ds by dt df. So we know that, so rate of change of displacement ds by dt is equals to velocity v. So as for this formula we can write ds by dt replaced by v. here also ఇక్కడ ఆల్రెడీ v ఉంది కాబట్టి v sub v స్క్వేర్ అవుతుంది. సో దీన్ని రాసుకోవచ్చు m ds by dt ప్లేస్లో I substituted v, సో mv dv ప్లస్ ఇక్కడ ఆల్రెడీ v ఉంది, ds by dt ఆల్సో v, సో v స్క్వేర్ dm. దిస్ ఈస్ dk is equals to mv dv plus v square dm is equals to ఏం సబ్స్టిట్యూట్ చేయొచ్చు ఫ్రమ్ ఏ v square dm plus mv, ఇక్కడ v square dm plus mv dv ఈ ప్లేస్లో c square dm సబ్స్టిట్యూట్ చేయొచ్చు ఫ్రమ్ 1. సో ఫ్రమ్ 1 dk is equals to దీని ప్లేస్లో c square dm సబ్స్టిట్యూట్ చేయొచ్చు. రీప్లేస్లో mv dv ప్లస్ v square dm by c square dm యాజ్ పర్ ఈక్వేషన్ 1. Now integrate this equation, kinetic energy from 0 to k. Integrate this equation. Now integrate above equation, kinetic energy from 0 to k. So integration above equation integrate చేస్తున్నా within limits, kinetic energy కాబట్టి within limits k c square dm. సో ఇక్కడ మాస్ within limits mass, సో rest sorry not to m, rest mass to mass. So integration dk, that is k, here c square is constant. So integration upper limit minus lower limit m minus m naught mc square minus m naught c square k. So this is the small kinetic energy. So total kinetic energy, so total energy means kinetic energy plus rest mass energy. Kinetic energy plus rest mass energy, that is rest mass energy m naught c square అంటే k plus m naught c square, that is the total energy రావాలంటే. So we know that k is equals to mc square minus m naught c square, mc square minus m naught c square plus m naught c square. So here minus get cancelled, is equals to mc square. This is the energy mass relation by Einstein, is equals to mc square.